All right, let's talk about doing an actual layout for a system. And normally this is an in-class example where I give you all 5 minutes and then start walking around and look at some of the examples that you have. Unfortunately, I can't do that in this kind of an environment, and it's very difficult for you to get together with 2 or 3 people and do this sort of thing. So I'll have to ask you to do this on your own. It is kind of important to work through a few examples, and you'll get a sense of just how difficult this sort of stuff is, even from starting from scratch, right? You've seen a lot of interfaces, but as soon as you're tasked with answering a question about what should an interface look like without really having lots of background or experience in this, you'll see just how challenging some of these problems are. So this is the standard ATM example, and you can look at the slides online on Blackboard to get the complete text of this. And all I'm really asking is to create a basic interface for problem statements like this. It's an important skill, not because it's going to be a critically important user interface or that you're going to get it right and no one will ever have to change it after you've created it the first time, but mostly so that you kind of get a sense of like what are the really important pieces of this problem from a user's perspective. It's very difficult to get that without actually sort of thinking through what would the user interface look like. I also wanted to show an example of why this is important in the context of this running example we have in this class. And this is a YouTube link that you can access from the slides on Blackboard as well. I may be able to put it in the description of this particular YouTube video as well. But it'll show you one of the major problems with ATM interfaces that's currently going on from a security and privacy standpoint right now. Normally, I'd click on this and we'd watch it in a classroom environment. But I think you can actually do that on your own. Okay, then I wanted to very briefly talk about interface design principles in this context, because we haven't quite finished everything that we need to discuss with high-level design principles. I've given you some basic ideas, things that you need to be aware of, things like consistency and layout and efficiency and that sort of stuff. But we haven't talked about like how do we actually go about doing the design. This is going to be different for basically every application, every organization, but the high-level principles in design are kind of going to be the same. You need to know what the inputs, outputs, and usage scenarios are, right? You want to identify them explicitly. This should be done in the requirements phase, if at all possible. Then you want to have some high-level overall interface structure that you're coming up with, and we'll talk about interface structure designs as a part of the at least the way the textbook describes them as a part of the later parts of this lecture. And you want to look at the standards and conventions that are appropriate for the domain you're designing for. Then you want to get into prototyping. This is different from the prototyping SDLC, right? If you're designing an entire system using the prototyping SDLC, that is something you can do separate from the prototyping of the user interface. Typically in that scenario, you're actually building a functional piece of software for the purpose of understanding what are the difficult parts to build, and that is an entirely different question from building a user interface or prototyping user interface and having focus groups and all that sort of thing. They can be done together. They do not have to be done together. If you are not using the prototyping SDLC, you are almost certainly going to have people in your design phase prototyping the user interface design. And then you want to have some evaluation of those prototypes. And most importantly for all of these things, you want to iterate. You want to continue to go back and look at these high-level principles and see have you actually covered all of them at an appropriate level of detail for you to be able to build a final system. So let's talk very briefly about identifying inputs and outputs in the context of some of the other things that we've talked about in this class. First, if you have a level 0 DFD, the inputs and outputs are just going to correspond directly to all of the data flows from a process to an external entity or vice versa, right? Data flows from an external entity to a process. Any process that is not fully automated, meaning not completely handled by the back end of the system, has to have some design around it. Okay, so any data flow between an automated process and a manual process has to have some user interface design because of the manual component there. For usage scenarios, which we've also talked about, you want to outline the steps that the user would take to actually accomplish something and use, if possible, any references to DFD processes in the design of the interface, right? In particular, looking for inputs and outputs. Most of the time, you want to have numbered textual steps in your usage scenarios so that you can then link them to design elements as you're doing the design. And I'll show you what that looks like in the context of an interface structure design in a moment when we get into interface structure designs. Most of the time, a usage scenario only represents one way that something can be done, and the actual user interface wants to support more than one way that something can be done. So even though you only have one usage scenario, you might actually have multiple design elements that support that scenario. Right? And usually the usage scenario is only going to be written to represent the most frequent uses of a system. There are going to be exception cases and infrequent uses of a system. Those still have to have interface elements designed to support them.